Chapter 5 Middle Childhood Cognitive Development. So, in this section, we will discuss an overview of cognitive development, the milestones of middle childhood, Piaget's theory and the concrete operational stage, information processing during middle childhood, and language development. So, an overview of cognitive development. Cognitive development is the processes such as perception taking, reasoning, and problem solving by which one comes to know and understand the world. So let's look at some milestones in middle childhood. So during this time, they have a rapid development of mental skills. They learn better ways to describe experiences and talk about feelings, primarily because they now have theory of mind. They have less focus on oneself and more concern for others. They're more realistic and objective. They face more academic challenges at school because of all the academic expectations and standards. They become more independent from the family. They begin to see the point of view of others more clearly. Their attention span is greater. They have deductive reasoning. They're able to compare and contrast and understand the consequences of actions. So let's look at Piaget's cognitive development theory. So Piaget's theory explains how people think and understand. So Piaget says that there are schemas, which is knowledge that everyone has, and we either assimilate that knowledge by taking in new information and adding it to what we know, or we accommodate those schemas by altering and changing what was incorrect or what was different than what we thought before. And equilibration is that balance between adding to what we know and changing what we thought we knew. And Piaget says that there's 4 stages. So middle childhood is moving out of pre-operational into concrete operations, which means they're starting to have logic, they're objective and rational interpretations, and they now have conservation, numbers, ideas, and classifications. So let's look at the concrete operational stage. So there's this 5 to 7 shift, which is that transition period between pre-operational and concrete operations, like I was telling you. So thinking is based on more intuition than logic during this time, and they do not fully understand the reasoning process behind what happens. However, as they age and get more mature, from ages 7 to 8, they move to the concrete operational stage. So concrete operations is the stage in which thought becomes logical, and it's based on realities and mental imagery. And then concrete means that they understand their environment. The understanding is limited to the present and to the immediate physical realities that they can see. So whenever I think of concrete, I think of this big, heavy rock block that you can see. It's heavy. I have to touch it. I have to see it to really understand. So abstract thinking and hypothetical thinking is not at this age range. They have to be able to see it and understand it for it to be part of their immediate physical reality. So some characteristics of concrete operational thought are classification, decentering, class inclusion, reversibility, conservation, seriation, understanding time, and their cognitive style. And we're going to talk about each of these in just a second. So classification is the ability to group objects according to traits of similarity and likeness. Now they had this in pre-operation, but now they're able to classify more than one attribute at a time. So an example of this would be classifying animals. So you got your vertebrates, and then you have your warm-blooded and your cold-blooded, and you're looking at mammals and birds and fish, and you're looking at all these different aspects instead of what's a bird, what's a fish. So it's a lot more detailed. Now, also during this time, they'll form collections of things. So when you think of commercials and toys that are focused towards this age group, you see things like collect them all. So like Pokemon cards and all these different surprise animals and all these toys that want them to collect, and they give them a checklist so that they can classify and see what they have and which ones they want. Very much suited towards that classification aspect of this age group. So decentering is the ability that allows a school-age child to attend to more than one aspect simultaneously. So they're now able to multitask or follow multi-step directions. And they can understand things like states of matter, so how water can be a solid, a liquid, and a gas. They can solve multi-step problems and they can sort and classify multiple aspects. So no longer are they tricked with these conservation tasks of which one has more, because now they can look at the number and the length, or the amount of mass, and if it's flattened, they can look at both of those. So they're not as easily tricked when it comes to those types of tasks. So class inclusion is the ability that allows a child to consider the whole as well as its parts. So it's focusing on one aspect in regard to a classification group. And examples of this would be like color and texture, or animals versus the name of an animal, and flowers versus the color of the flowers. So here's an example here. So a typical class inclusion problem in which children are asked is whether there are more dogs or more animals in the picture. Well, they would have to know that all of these are animals. So they would have to count up all of these and all of these. But for younger children, they would count the dogs, then they would count the cats, and then they would say, there's more dogs. But the question really was, is there more dogs or more animals? So same thing with the flowers. Are there more blue flowers or yellow flowers? So are there more flowers or are there more yellow flowers? So they would have to look at it from two different aspects of a whole. So reversibility is the ability to understand that certain operations can occur in their reverse order. So when we were in school, you probably had a teacher that said, check your math or check your work by doing the opposite. So the opposite of addition is subtraction, and the opposite of subtraction is addition. Same thing with multiplication and division. They're opposites of each other. And you can do the inverse to make sure that your answers are correct. So for instance, 4 plus 2 is 6, and 2 plus 4 is 6. But if you did your math and you did the opposite, 6 minus 4 is 2, and then 6 minus 2 is 4. So you can do the inverse to see the difference and to make sure that your work is right. But now they can actually go back and forth between the two. So now they're going to start learning about the distributive property and the commutative property, and they're starting to understand a lot more about mathematical concepts due to this reversibility. So conservation is the ability to understand that essential characteristics of something are preserved even though it is rearranged in different ways. And this is known as horizontal logic. So unevenness in applying an understanding of conservation problems across different contexts. So what this means is that they may have an understanding of volume, but they may not be able to understand matter or numbers. So one of the first ones that most children do master is the conservation of numbers. So having them, which one has more, and then spacing them apart. They master that one pretty quickly. But things like volume, taking one glass to the next, they may have this one mastered, but this one may take a little bit longer. So they're not able to apply the same knowledge to different contexts. So seriation is the ability that allows objects to be scaled according to various dimensions. So examples of this would be like large to small, small to big, great to greater, great to least, least to greater, and then using the greater than and the less than symbols. So they start off pretty simple with small to big, and then sometimes, and we know we're all guilty of this, of doing the wrong seriation. So the teacher may ask us to do greater to least, but we did least to greater. So being able to understand which one is what they're asking and to be able to scale it out that way is a very important milestone in this age group. And it builds in complexity. So it starts with simple numbers and shapes, and then it moves to fractions and decimals, and it just gets harder. It just gets added, not harder, but more complex, and adding another layer to it. And that's why foundation skills are so important. So understanding time is another thing that is during this age group. So they can accurately state what day will occur 3 days from now, and they have judgments of time span, and they also have knowledge of calendar events, and they can tell time. They can understand the differences between days, week, months, and years, and understand routines. However, they're not capable of working backwards in time and understanding past time yet. So, for instance, that a train leaves the station at this time and arrives at this time, they cannot abstractly do this type of time yet. It's going to be acquired later in adolescence, but they can do a lot of the foundation things like telling time, understanding 60 seconds, 60 minutes, how many days are in a month, how many days are in a year. They can get that, but working abstractly is still a little difficult for them. So, cognitive style, it's less egocentric at this time, and they use logic to infer. And thinking is bound by distortions and reasons. So they do make many errors in their logic as they attempt to understand why people do what they do and why the world works the way it works. Now, cognitive conceit is a characteristic thought in which people perceive situations and people in black and white or all or nothing types of thought. And it limits the understanding of complex human behavior. So, an example of this would be if a teacher makes a mistake, children might conclude that he or she must often be wrong when teaching. But if a teacher gives a correct answer, children might think that he or she is the authority of all issues and all topics, even if they are just the math teacher or just the English teacher. They think that they know everything. So they really don't understand that people can be smart in some things and not, or competent or capable in something and not in something else. So there's a lot of things that they're still developing and understanding about other people and how we're all complex individuals. So we're going to pause and process about what we have talked about so far. So go back and review as needed to address these questions. So information processing during middle childhood. So information processing, like we've covered before, is that computer model. It's the way that we take in information and we store it or forget it, or we go back and retrieve it and change it over time. So there's a lot of changes in information processing during this age, and they primarily deal with attention, memory, and metacognition and meta-memory. And we're going to talk about each of these in just a second. So attention, this age group now understands that they have a better understanding of attention, and they understand it's selective and it requires processing. That you can't just learn something or get something without focusing on it and without trying to do something with it. So selective attention is that ability to tune out distracting stimulation while performing tasks. Now again, that is a very complicated thing for certain children to do, especially up until the age of 10, because that's when the brain is matured to help allow that. So an example of that would be tuning out music while working. Middle childhood can do this. Not all of them, but most of them can. Whereas in early childhood, they would not be able to focus on their task and listen to music at the same time. It's also the ability to distinguish between attention and comprehension. There's a difference between listening and hearing it and being able to do it. When they're younger, they think that they can just do it and be able to get it through absorption and just hearing it. But that's not true, because learning is a construction process. You have to pay attention to be able to apply it and try and practice what it is that you're doing. And their ability to differentiate attention comes particularly from instruction and from cues from adults. So it's what the caregiver or teachers are doing. So if it's really important, they may say, write this down or focus on me, and they'll model how to be successful. So, memory is the ability to process information received from the environment, and recall allows people to compare new information with previous information, and that's part of that information processing computer model. Now, memory improves in middle childhood because of the improvement in attention span and that brain development, that maturation, and the strategies that teachers and parents and caregivers give to the children. So there's three phases of memory. There's the sensory register, the short-term memory, and long-term memory. So the sensory register, this is the first memory storage location where sensory information is stored in the brain before becoming short-term or long-term memory. The storage is only for a brief time, often less than a second. So it comes in and it either goes to storage or it's deleted. And the form of memory functions at adult levels by age 5. So they're able to remember things and store it into memory, but knowing what to focus to is a completely different thing. So the sensory register registers all the sensory impulses, so sight, sound, smell, taste, touch. And what we do with it is the important part. So we either initially process it and put it into our working memory, or it's not transferred to the next stage and we forget it. It depends on if we see a relevance in paying attention and storing it. So short-term memory is the initial memory storage location in the brain where information remains for about 1 minute before being erased or placed into long-term memory. It all depends on the connection made with it and the relevance and if the learner deems it important. So this is a recall of information, events, and so on that are relatively recent. It's what's happening right then. So short-term memory is in the prefrontal lobe here, and not everything that we see and experience goes there. So only the focusing on a selected portion is what we get. And this is that selective attention that controls what information goes to the short term or the working memory. So long-term memory, this is the final memory location in the brain where information is stored indefinitely. And it's the recall of events in the past present, or the past distant past, excuse me. Now, there's two different types of long-term memory. You got your declarative memory and your procedural memory. So semantic memory falls under declarative, and it concerns knowing what. This is memory for meanings, so knowing the meaning of words, but again, you kind of lose it if you don't use it type thing. So where it gets stored is really important. And then episodic memory is concerns with when, where, and what. So these are your personal experiences that were exciting or emotional. So these are kind of your mental movies of your past events. Now, procedural memory, these are memories concerned with knowing how to do things. And often this memory is automatic and is resistant to forgetting. So things like driving a car, waking up in the morning. These are what we are going to talk about, are scripts that we kind of do on autopilot without even thinking about them. So scripts, children become better at memory because of the improvements they experience. And scripts are an organized series of acts committed to memory. And most scripts are routine events in one's daily life. So things like getting dressed, driving a car, brushing your teeth, classroom procedures. And these steps are, like I said, very unconscious and stored in long-term memory for repeated recall. And the only time, especially in middle childhood, it's addressed, the scripts are addressed, is when the child is not necessarily doing what they know they should be doing. So having those prompts of reminding them what to do is really important when they're not on task, or it becomes habitual and they have a distorted script of what the expectations and procedures are. So metacognition and metamemory. So we've talked about metacognition before, which is the ability to be aware of and understand the changes occurring in one's cognitive process. So it's your ability to pay attention to things and to remember these things and to be able to apply them later. So it's knowing about knowing, learning to learn, being able to be reflective. Meta memory is an awareness of the extent of one's memory. So it's the ability to use strategies to help you remember, which builds your metacognition. So both of these are self-evaluative processes about one's thinking and memory. So, for instance, depending on what type of strategies you've learned in the past, some of you may currently be taking notes. And the reason you take notes is because that's your way of remembering key details. Some of you may be accustomed to remembering and memorizing things as you go, and you may forget some things. It all depends on your strategies. Other strategies for memory are things like flashcards, um, open-ended questions, study groups. There's all these different things that we do, but you have to pick the ones that are best, because there's sometimes where fact cards don't work well, or when it just all depends on your task at hand and what helps you the most. But that metacognition part is you being able and aware of what you need to prepare and to be successful. So whether that strategy is going back and reviewing the slides that I have in Google Drive for you after I've talked about it with you, or going back and playing the video again, or going back and looking in the book, those would be all part of your meta memory, your strategies that you're picking, and your metacognitive process. But children at this age have to be taught how to think about their thinking and how adults think about their thinking. So going and doing I wonders, or I think alouds, or I bet I should write this in my notes, or taking notes with them so that they know that they don't have to write everything that's on the slides down. So helping with that process is very important. So intelligence is the ability to solve problems and to adapt and learn from experiences. And there's two main views on intelligence. There's the traditionalist and then the new view. So traditionalists view intelligence as a gentle mental ability. So intelligence is fixed. It's measured by a number, an IQ test. And intelligence is isolated. It's measured in isolation. It's not in regard to context or a subject, or and then others view intelligence according to various mental abilities. So intelligence can be developed. For some people, they believe that you can grow in your intelligence. That's known as a growth mindset, compared to the old view that says that it is fixed, which is a fixed mindset, where people think that there's nothing you can do to improve your intelligence. But the new view says that you can, within reason, develop your intelligence if you practice and try new things and learn new strategies and ways of thinking. The new view says that intelligence is not numerically quantifiable. It's exhibited in performance and problem solving, and that intelligence is measured in context in real life situations. So it's how you apply your intelligence to things. And then intelligence is used to understand human capacities and the many and the various ways students can achieve things. And one of the major theorists that talks about this is Howard Gardner and his multiple intelligences theory. So Gardner claimed that intelligence manifests in many different ways, and people can be smart in different ways. And he says there are 9 different ways of showing intelligence. So there's interpersonal, which is communicating with others and reading them. So inter means within people, using that prefix inter. Bodily kinesthetic would be the coordination between the mind and the body. So athletes, dancers. Linguistics would be using language in the form of writing and speaking. Intrapersonal is you, so the ability to understand your inner self. Natural is about connecting and understanding the nature of the world. Spatial, experiencing the world in 3 dimensions, so being able to think abstractly about different terrains and blueprints and how you can fix something by just looking at it and thinking about it. Musical would be recognizing sound, pitch, tones, rhythms, and timbre. And then mathematical mathematical logical would be excelling in math and logical thinking. And then existential is the introspect questions about life, death, and existence, which is a little different than intrapersonal, which is more about yourself. The other one is more about life and why we exist in the world. So, middle childhood mathematics skills. So, just like early childhood, there are foundational skills that are built upon in middle childhood. So, going back to that, they were learning how to count, they were learning how to solve problems using manipulatives, they were getting conceptual understanding of what numbers represented. Now, school age children are expected to master these basic operations because they should have already developed their number sense and their understanding of classification, shapes, patterns, and things like that. They're still working on some of these, though. So they're expected to build on their mathematical foundations in terms of codified math, algorithms, and inventive strategies. And by the end of middle school, they're now moving towards understanding fractions, decimals, pre-geometry, pre-algebra, and conversion between the decimal and standard systems of measurement, which takes a lot of those foundation skills into account for them to be able to be successful in these higher level math skills. So codified math is math that is written systematically, it's systematically arranged and guided by explicit rules. It cannot be learned through exploratory learning with manipulatives and things like that. It's taught through formal instruction. So teachers have to be very, very careful though, even parents, because some of the things that we were taught may be incorrect and that can have a hindrance on their future math ability. So we have to be careful because some of the teaching, so when we're teaching rules, some rules are not always true and we have to be very, very careful. For instance, a rule that is negatively transferred is when you divide two numbers, the answer is always smaller. That is true, but not with decimals. When you divide a whole number in a decimal, the number is actually bigger. The answer is bigger. So there's some rules and tricks that we were taught, or tips that we were taught when we were younger that do not apply as we get into higher level math, and we have to be very careful. So here is a link I'm going to share with you in just a minute that talks about math rules that expire in middle grades. So it's things we were taught in the foundationals, but when we get to a certain level in middle childhood going into adolescence, it can cause a hindrance in our ability. So here is an example of codified math properties. And these are just things that we are just taught through formal instruction. So knowing what the commutative property of addition and what those are. So being able to look at it in terms of addition and then of multiplication so that we understand when we're asked a question or it's flipped or it's shown in a different way, what it means and represents. But we would not know those words through exploratory learning. We would not know that it's an identity property of addition when a number is added to zero. We would not know that through just playing with it. We were taught that formal language. We were taught what it looks like and what it means and what it represents. So algorithms have been developed and codified over centuries and produce correct results. Now, when used properly, algorithms will always work. So using things like formulas, perimeter, the Pythagorean theorem. Same thing with doing math, going in and breaking it down and doing the formula. So taking a 10 and moving it over to the 1 to make it 11 and understanding what that means. Conceptual knowledge is very important for them to know this is the hundreds place and this is the tens and this is the ones and why we're taking this down to 40 is what it really is and bringing a 10 over to make this 11. What that really represents and what that really means. So, inventive strategies, this is where one uses their own knowledge and current strategies to help them in answering problems. Now, a lot of you probably have heard about Common Core math and you think that this is so different than what you were taught. But what it actually is doing is giving them strategies to help them solve problems on their own in many, many different ways. So, an example of this would be, for instance, 103 times 9. Well, what that means is this is the hundreds place, the tens place, and the ones place. Well, if they have a concrete understanding of that, they could say, okay, well, 100, I can take 100 and multiply that by 9. And then I could take the ones, because 9 is a 1, it's in the ones place, and multiply that by 9. And that's a lot easier than trying to do what you were probably taught as borrowing and carrying and bringing the zero down and all of that. It breaks it down and makes it easier. So they can go, okay, so 9 times 100 is 900. And then 3 times 9, I learned that when I was memorizing my multiplication tables. That's 27. And then they just add it together to get that number instead of going, okay, 9 times 3 is, 9 times 0 is, oh, but I got to bring that down. 9 times 1 is. They can go through that process and it makes more sense because that's what it means. Same thing with this. 29 plus 1 plus 17 is 46. Well, what that number really means is 20 and 10, because that's what's in the tens place, 9 and 7, 16. And then they just add those together. So 30, so that means 10 and 6, so 40. 40 plus 6 is 46. And I know a lot of you are going, well, that's just really hard and not needed. But it gives them a way of solving the problem in a conceptual way so that they can pick which method they want. So if they want to use this way later, that's fine. But as long as they have a conceptual understanding of what it means. Same thing with multiplication. 3 times 5 is 15. You can memorize that. But you could also draw it out in groups. You can also do it as a rectangular array. So 3, 6, 9, 12, 15 to figure out what it is. Or repeated addition. All of that will get you to the same answer. So that is what inventive strategies are all about, is finding where you are in your ZPD, your zone of proximal development, so that you can answer the problems that you're going to encounter. So middle childhood language arts skills, reading. So children by this time should become fluid readers during this period. So they're not necessarily working on phonics and sounding out words. At the beginning, children are reading. Their reading is focused on sounding out the words and identifying it. But comprehension takes fluency. So if you're spending all your time trying to sound out the word, it's going to be really hard for you to comprehend what you're reading. So there has to be a balance between reading the words, because some children need to keep reading so that they get the phonetic parts and are able to read the word on the page. But actually being able to take what they just read and understand it is a whole new level in middle childhood. And then their passages just get longer and their vocabulary gets more complex as they get older. So they have to have a basic cognitive skills set. So they have to have phonological awareness, processing, attention, automaticity, which is that fluency, being able to do it, their memory, and their sequencing. To have reading fluency, and then reading fluency falls into reading comprehension. And then when you get older and you're reading with metacognition to understand life experience in different contexts and different skills and different manuals, that's where all of it filters up together. Now, fluency for this age range, again, this is going to be going from about 1 going to about 6th grade. It kind of shows you where they should be reading in regard to their words per minute. Now, WCMP means words correct per minute. So by 6th grade, they should be reading 120 to 160 words, which is a big difference from 1st grade where they were reading 30 to 60 words correct per minute. So it doubled from 1st grade to 6th grade. So, middle childhood and their writing. So, writing goes from simply stating facts to coherent and organized pieces. So, they start writing more of essays and paragraphs. And primarily at this age, it's used to see what students have learned. And they learn how to write different types of pieces, such as stories, reports, informational texts, narratives, poems, book reports, all sorts of different things. And additions to their writing do include things like a thesis statement, introductions, transitions, topic sentences, summaries, a coherence across what they're talking about so they don't start talking about a book and then start talking about their cat. And then organization, and then they have advanced grammar and mechanics. So as you can see from this, this is a writing about Diary of a Wimpy Kid, Roderick Rules. And we can see that there are still a couple errors and things in here, but we can see some really good things from this writing. So Diary of a Wimpy Kid is a book by Jeff Kinney. Well, first off, books should be underlined and you capitalize. So that would be something as a teacher I would want to work on. It's about Greg getting in trouble from his brother, Roderick. Something I do see is that they know how to use contractions. A little grammatically incorrect there. So it's about Greg getting in trouble from his brother. But also, look at that. They have a comma because he could have just said from his brother, period, but he wanted to tell you the brother's name. And the brother's name is Roderick. Now, something that's inconsistent you may see here is Greg and Roderick, that's lowercase, but this one's uppercase. So I don't know if it was by mistake or not. So Greg and Roderick threw this big party, and he's blaming it on himself and his brother. So he's having the worst summer ever. Now, that is a giant run-on sentence. So there would be another thing. But we can see that there are some foundations. And that if we keep going, then they in trouble with his parents. We're in trouble with his parents. So we can see that there's some transition words starting to a new paragraph. So this is my favorite part, and then going to the next part. But you can really see how it has really changed from that scribbling and from that one sentence. Still a little grammatical errors. Were, for instance, having trouble with the dropping the E and adding ing. So there's a couple of things that are still there that need, and those would be fine-tuned and developed through middle childhood and into adolescence. So we are going to now pause and process what we have covered so far. So go back and review as needed to answer these questions. So language development during middle childhood. So going back and looking at those 5 language things. So phonology, the sounds of words, semantics, the meanings, syntax, grammatical rules that govern sentence structure, pragmatics, the social rules of language and how you speak and when you speak it, and then morphology, how to change rules in regard to tenses and using prefixes and suffixes. So during this time in middle childhood, they are doing a lot of different things. And this builds on into adolescence. So they're starting to pronunciate like adults. They have dramatic expansion of their vocabulary, especially since they're in subject area things where they're learning about science and history and all these different aspects. So they're starting to learn abstract words, especially in adolescence. Their appearance and self-refinement of their semantic integration. So they're starting to really understand how to put things together. Morphology and syntax. So they have acquisition of morphology knowledge. So they know about prefixes and suffixes and how to use those to understand what they're reading. Their correction of early grammatical errors, but there's still going to be errors. And then the acquisition of complex rules when it comes to formal and informal language and things like that. And their referential communication improves, especially their ability to detect and repair uninformative messages once sent. So they're able to, if they say something wrong, they're able to fix it or they're starting to think about how to be more responsive and direct and intentional with what they say. And then metalinguistic awareness blossoms and becomes more extensive with age. And we're going to talk about these more in detail. So, language development, they're continuing to improve in many, many different aspects. Their vocabulary is growing, and again, this is primarily because of their content area classes. They're really starting to learn a lot about different things. Now, in younger grades, it was more of a blow or an explosion because they were learning how to read and they were learning how to decipher what they were seeing with symbols, and now they kind of have this basis, but now they're learning more academic language. They're in they're continuing to improve their word choice, and this is primarily because they're learning new vocabulary and how to use prefixes and suffixes and all these good things. And they're starting to understand figurative language and use it. Syntax, so they're understanding subject verb agreement, verb tenses, double negatives. And then morphology, they're starting to understand how to use irregular words properly. So instead of saying childs, they'll say children, or gooses, they'll say geese. And they're also continuing to improve in their pragmatics and how they have to talk to different people in different situations. Metalinguistic awareness does develop during this time, and this deals with the capacity to use language to analyze, study, and understand language. So it's their ability to treat language as an object and separate from the meaning it conveys. So what they will do is when children begin to learn to read, they see words represented by letters on a page, but they start to discover what the words and sentences may have multiple meanings. So an example of this would be a 5-year-old would say drink the chair, and their reaction would be silly. And then eat or cake the eat, the reaction that it's wrong. And then why is a caterpillar longer than a train may be a riddle. But understanding those different elements of how things are said and what reaction you want from it, and is it meant to be a joke? Is it meant to be taken literally or figuratively? That they're starting to develop. So we are going to pause and process and go back and review as needed to answer these questions. And that is the end of this section.